Do you remember playing with chalk as a kid? Adding some color to the sidewalk, getting a message out, maybe even playing some hopscotch? Ha, who am I kidding? Hopscotch was too old even for me. If you revisited chalk today, you might notice that there are a few factors that can affect how fast you destroy it. By changing how fast you move the chalk, applying different amounts of force, or changing the surface of your temporary masterpiece, you can end up with very different looking sticks of chalk. Playing with chalk is a good way to demonstrate some of the concepts from a chunk of science that we like to call tribology. Welcome to the world of rheology. The word tribology comes from the root Greek words of tribos, meaning to rub, and ology, meaning to study. This gives a pretty self-explanatory idea of what the field is about. In order to do this comprehensively, tribology incorporates elements of friction, lubrication, and wear in such a way that information can be gathered about the systems being tested. One thing that is important to note, however, is that friction is a system property, not a material one. That means that everything that is involved in that test matters. Not just the material of interest, but the surface of contact, if there is a lubricant present and how much, and what the environment is. If any of these parameters are altered, you are now dealing with a new system that may have different properties. So now that we know what tribology is, let's get acquainted with some of the terms and dig a little deeper into the science behind it. As good a place as any to start would be with friction. Friction is ultimately a force that opposes the direction of motion. Friction relevant to rheology can be divided into three types. The most elementary of the frictions to understand is that of static friction. Static friction is the amount of friction it takes to hold something in place without it being able to move. Sliding friction is the next easiest, and it is a resistance to a sliding motion across a plane after an object has begun to move. A good example of static versus sliding friction is when you attempt to push a box across the floor. Once the force being exerted against the box has become greater than the static friction force, static friction has been overcome. The box is now in motion, and now sliding friction is the resistance that the box is experiencing. The last type of friction relevant to rheology is called rolling friction. Rolling friction is the resistance that a surface provides against an object rolling across it. An example of this would be a car tire rolling. The surface that tire is traveling over will affect how much resistance to motion the tire will experience. When there is any type of friction occurring, it gives the conditions for wear to occur. Wear is the removal of a material and can present itself as a variety of different behaviors. Most commonly, wear is observed in tribology as either adhesive or abrasive wear. Adhesive wear happens after two surfaces have become stuck to each other through contact. During the separation of these surfaces, material transfers from one of the original surfaces to the other. An example of this would be applying tape to a piece of paper and then peeling it off. The paper has experienced wear and transferred material to the adhesive of the tape. The other type of wear related to tribology is abrasive wear. This occurs when friction between one surface physically removes material from another. A good example of this would be rubbing sandpaper against wood. In this system, the wood is experiencing a great amount of abrasive wear, while the sandpaper is experiencing significantly less. The last element of tribology is the role of a lubricant if it is present. The goal of a lubricant is to decrease friction and reduce wear within a system. Not all lubricants are effective in any given system though, meaning that a good lubrication in one system may not be very effective or may in fact be counterintuitive in another. Putting all the elements of tribology together can be used to study a variety of different systems and gather information about a variety of different applications. Many of these are dealing with elements of engineering because the information gathered during the testing can be used in place of conducting much more elaborate and extensive tests. In the same way that engineering tests model other applications, Food researchers are finding ways to model tests of how food is processed and even how it is perceived during consumption. Grating cheese is a good example of active tribology being performed on food. As the cheese is slid over the grater, the cheese experiences friction from the shredding surfaces. These surfaces wear off bits of the cheese, which becomes pretty evident by the decrease in the size of the block. Different types of cheese will experience different amounts of wear from the same amount of force applied to the grater. This is because of difference in the cheese's material properties. One thing that may be noticeable is that cheeses with higher fat content may slide down the grater more easily, but this may not be the case for lower fat cheeses. Since there are many different types of food products, each with their own processing needs, it is important to make sure that you have the right tools at each stage of processing. By performing tribology testing on different foods or materials used in processing equipment, scientists can also model processing conditions experienced in a manufacturing facility. This can be important for selecting components in plant design or for designing process lines for producing foodstuffs. Another area that tribology can be applied to is your mouth. Using tribological models, scientists can model teeth and the soft palate of the mouth to predict how food breaks down and is felt during the course of chewing. These models can be correlated to models of sensory analysis data, which can quantify the sensations that a person may experience while eating. This is very important, allowing food companies to make products with a greater acceptance, and they may reach a larger audience than ever before. As we have shown, tribology is a very diverse field that is finding a broad range of applications. Hopefully this video has taught you something, and now maybe you can start to see examples of tribology in your daily life too. If you look hard enough, you will find that you are completely surrounded by them. I hope that doesn't tribose you the wrong way. Until next time.